Alrighty. Streak broken from the hard one yesterday. Still pretty close, I think. Made some adjustments, but I never got to an answer, so maybe at some point I'll finish that one. But anyways, count elements with maximum frequency. Previously solved this one. That's easy, so I guess I can read it again. You're given an integer, you're given an array of numbers consisting of positive integers. Return the total frequency of elements and nums such that those elements all have the same maximum frequency. The total frequency of elements and nums. So I think here, okay, so 2 and 1 both have the highest frequency of 2, and the total sum of those values, or the total count of those values, is 4. Here, everything has a maximum frequency of 1, and there's 5 stuff, so there's 5. Okay, so I think I probably use counter. Counts is going to be, frequency is such an overused term in this one. Right, I'll use counts is a counter from the nums array. And then what I want is the maximum. So max count would be the maximum of counts dot values. Counter has the actual numbers as the key, and the count as the value in that mapping. And then I want to see how many of those numbers have that max count. So let's say max max terms for every number and count in counts if count is equal to the max count. Max terms, actually I think I just increment here. Answer is incremented by the count, or answer max count so the same in the point. I think there might be slightly faster ways of counts to items. I wonder if there's a way to iterate through a counter object. Iterate over counter object in Python. For every element. Okay. So you have to unpack the element at that point. Or you can just use .items. In any case, probably pretty fast. Okay, I mean 3 milliseconds is fast, but not relative to the other solutions. So let's see if I can't slightly change this. I get my counter, and it's possible Okay, maybe I do something like this. Let's say I do max count is actually equal to 0. And I do an if statement where if the count is equal to the max count, then answer increments by the max count. Else, if the count is greater than the max count, then the max count equals this count. Answer is equal to this count. So I could do something like max count equals answer equals count. Okay, that allows me to get rid of that call. Made it slower. Excellent. I guess there's two conditions here. I guess here, if I can, if count is less than max count, then continue. In that case, I don't have to do the other if checks. Like the most likely thing to occur, and then the second most likely thing to occur, and then finally this thing. I don't need a condition check at that point. I guess I can do else if here. Okay. So I mean, it's like optimization and conditionals. Okay, guess that works. Count less than max count, which is most likely. Most of the time, you'll see something that is not as frequent as the highest frequency. So the other arrangement of the conditions of the if-else statement, you have to check multiple conditions to get to that outcome, to that most likely outcome. Okay, let's go ahead and maybe max count equals answer equals 0 here. Also, this could just be random variation of getting to 0 milliseconds. Summary. So use a or create a counter object to quickly get the num/frequency pairing from the nums array. Pairing. Then have a answer counter variable or an answer variable and max count variable. Iterate over the num frequency pairings in counter and ignore if count and do appropriate kind of conditional appropriate conditional logic on them if the current frequency is higher than stored. Max count, update answer to current count, and max count to current frequency. And then like do similar logic for other two cases, like 3 cases being if the current frequency is less than, equal to, or the maximum stored max count. Okay, time complexity is going to be O of n as creating the counter object and iterating over them over their items both require looking over all n terms. I mean, in theory, counts the items could be as large as n if each item has one frequency. In practice, it'd probably be much less, but yeah. Space complexity is going to be O of n to have counter object, which in theory could have n items if every value in nums is one frequency, like in the second example where you have 1, 2, 3, 4, 5, the counter object would have 5 objects, 5 items, 1 with 1 frequency, 2 with 1 frequency, 3 with frequency, so on.